This is Mohsen Azimi, and he works as an engineer at Lyft, where he's focused on front-end infrastructure. And today he's going to be telling us about end-to-end type safety with Swagger and TypeScript. Please welcome Mohsen to the stage.
Thank you, everyone. As he introduced me, my name is Mohsen. I'm going to talk about end-to-end type safety with Swagger and TypeScript. Before doing that, I want to make sure that I can go to full screen without that top bar. How do I do that? Enter full screen. Oh, right. It's a Chrome bug, or oh, I see. Whew, thanks. Lots of experts here. Thanks. All right, so first I'm going to introduce myself, and then we're going to dig into this topic that I'm going to present. So I am a big fan of TypeScript. I have worked on Swagger tooling and helped authoring the Swagger spec. You can find me on GitHub and Twitter, and I have a little website that you can look at. In the Swagger team, I built this Swagger editor UI for editing Swagger spec. This is before I joined Lyft, so I used Uber's API as a default. But it is a well-spec API. We could use it as an example. And this is an iframe. I can actually use it here. It's pretty cool. I also worked on this TypeScript transformer that converts your React code that you have written in JavaScript with prop types to TypeScript with proper typing, because React's prop type system is good enough to get that type information. I also have some open source projects that I publish it on NPM. I love working on open source. But enough about me. Let's talk about this fundamental question that we all had since we were 2. Bugs, where do they come from? What happens when we have bugs? So to me, there are 2 categories of bugs. You either have a logic that is wrong in your code, or, for instance, here. This is a just made up function, let's say in Lyft code base. There is this function that adds user rating when you finish your ride to the right. And we want to report drivers that are getting really bad ratings. So it means, like, if your rating is 1 or 2, we want to report the driver. But here, the logic is obviously wrong. If the rating is less than 4, which is also include 3, we are reporting the driver. So this is one sort of bug that you didn't understand the requirement of your software that you're writing. But this is, to me at least, this is less common. And more common is this sort of bugs. This is, again, from Lyft's code base. Somebody forgot to return, and nobody really caught it. So this led to a big problem. We had an incident because of it. And when you look at the change, it's pretty simple. It's like this function expression here did not have a return statement. Bad. Or this is more like issues that TypeScript can catch, right? Calling .match on a thing that can be a string or can be something else. Again, these sort of bugs that are the bugs that happen a lot, and we can definitely prevent them. So a colleague of mine, which he is also a big fan of TypeScript, started commenting on these issues that could have been prevented with TypeScript. So we had a collection of these issues that we could refer to when we went to propose this idea that we should migrate everything to TypeScript. Luckily, a lot of engineers at Lyft, they worked with type systems before, and they understood how useful that could be. So we got accepted to make our proposal to make TypeScript the first language in Lyft was accepted. So what we did was we started migrating everything to TypeScript. Every JavaScript code at Lyft has to be in TypeScript, at least in the near future. I wanted to touch on how the TypeScript migration went. This is not exactly part of this talk, but I want to kind of share this experience with you guys. So if you have a large organization that you want to migrate to TypeScript, you might have the same feedback. So let's start with the good parts. TypeScript is a superset of JavaScript, so every JavaScript code we had, we could just rename it and become a TypeScript code. That's a huge advantage, because if you had to use some other languages that have different syntax, it would be much, much more expensive. So this is very, very important. The other thing is the well-typed packages indefinitely typed. So every package that we were using, we use Angular 1, we use React, we use Lodash. All these popular packages are well-typed in the definitely typed package. And the other really nice touch in migrating to TypeScript is these type errors that we think, oh, TypeScript compiler is wrong here because this code is in production. And then we dig in more, and say, oops, yeah, this was us. Compiler is never wrong. So, but there's also some negative part. Like one experience that we had was a lot of engineers, they didn't like to learn a new syntax. They were like, I'm coming to work every day working with JavaScript. I'm fine. I don't need to learn this new language. And that's really fair, because everybody has their own priorities in their teams. They want to ship these products. They don't want to hold up their product deliverables because of a new language. And sometimes these TypeScript type errors are really hard to find what's wrong with my code. And that is something that probably TypeScript can improve on. But overall, the type errors are very useful. And sometimes these type errors are not the code type error fault. Sometimes these type definitions across different versions are colliding. You had this experience probably before, where you depend on this package and that package depends on different version of Lodash, and the versions colliding. And I think TypeScript solved this recently, but this is from almost a year and a half ago. So, you know what happens when you migrate to TypeScript? No more bugs whatsoever. We didn't have any more bugs. It was beautiful. Every code that I was writing, it was perfect. But really? No, right? You know that that's not what happens. If it was happening, we would lose jobs. So thanks God that's not happening. But again, some bugs came up that it wasn't the logic bugs. This wasn't something that somebody didn't understand the logic right. They just mistyped this member of this. By the way, here document is not window.document. This is a rental agreement document. So again, this bug, which here in the description is more clear, it's a type error. This is something that a type system could have caught. But this object that we are working with, this document object, is coming from an API, and we don't know that API response, so we have some interface in our repository that represents what this API returns. But that API decided to return last updated at MS instead of last updated MS, and broke us without us knowing it. So what happened here is a phenomenon that I call the lost types. At Lyft, we value types very much. In the server, we have lots of Python, lots of Go, and Python code is strictly typed with MyPy, and we also use gRPC between services when they talk to each other. So everything is strictly typed, very nicely typed. In the client, we pushed for TypeScript with strict mode. So here is also, we have super tight type systems. But in between, these types are being lost. HTTP and JSON are not made for transporting types across the wire. So this is what happens. Server decided to say last updated at MS. They have updated their types, everything, but they didn't tell us, and our code broke. So this raises the question, what if these two type systems could talk to each other? If they could talk to each other, the Python backend could tell the front end that, hey, this is now last updated at MS, so the front end could react to it. So here is where OpenAPI or Swagger become very useful. So in short, OpenAPI or Swagger is types for your JSON-based APIs. You're all in TypeScript conference, so you should like OpenAPI, because this is all about types. I'm going to walk you what Swagger is and introduce you to the syntax a bit, so we can take it from there. So what is OpenAPI? As I said, this is an API specification format that specifies what your API is looking like, what endpoints there are, what operations that I can perform on those endpoints, what type of JSON they return, or what arguments they get. All of that is specified in this specification format. And this is built on top of existing standards, so it's pretty easy to pick up if you know how URLs and JSON and HTTP works. And it is open source and open government by the Linux Foundation. So it is something that doesn't have a vendor lock-in for you. It's pretty open. This is how the API documentation looks like. So if you have a nice documentation for your API, you also get a very well-designed and beautiful-looking API documentation out of it. You can even try API endpoints in this documentation, which is pretty cool for developers to learn how this works, how your API works, I mean. So here is a small subset, a very small Swagger definition that I can walk you through. So the first property tells you what the version of the Swagger is. Oh, by the way, this is a YAML document. And you can also write Swagger in JSON. But YAML is preferred because configurations are always in YAML, I guess. Then there is this info section. The info section can provide this header for your API. So here, this header section of this API documentation is generated off of the info section. It can have a lot of different properties here. But the more interesting part is this path map. So basically, this is a map of endpoints to list of operations. For instance, this small API that we have here has one path /foo, and one operation can be done on this path. And this operation gets one property that is in query, meaning it is in the question mark search params section of the URL, and has one response. It always returns to 100, and that's the schema for the response. So as you can see, this is leveraging the HTTP standards. Like this number 200, this is well spec'd in standard bodies, that 200 means it's okay response. Or this verb name, get, is also well spec'd. You can't just use arbitrary verbs. Every verb here is well spec'd. It is also built, as I said, it's built on top of standards. It is using URL as a standard. Surprisingly, URL is very, very complex. Like understanding how URLs work, it takes forever. So it's, at least for me, it took. So this is leveraging existing spec for URLs. So when you say this parameter is in query, all of these corner cases about URL is going to be taken care of if you use this spec. It is also built on top of something called JSON schema. So JSON schema is another standard that describes JSON objects. If you have a JSON object, you can write a JSON schema that describes what this JSON looks like. If you ever use VS Code and you start writing a JSON file, and then you automatically get these autocomplete hints, you might have already used JSON schema, because VS Code generates a JSON schema off of your JSON and then feed it back to the autocomplete engine, so it gives you these autocomplete hints. So with JSON schema, you can describe any JSON object. And this is where types are being transported between backend and the server, backend and the client. So by the way, Swagger can also describe your security schemes. If you use OAuth or basic auth or any other sort of auth, Swagger can describe that in the definition. This definition here doesn't have auth in it because it's kind of verbose, but once you need it, you can go read the docs and add it to your documentation. So let's talk about API, Swagger use cases. One easy way of using Swagger is to sit down and write a spec of your API, because you know how your API works, and put it in a middleware on top of your server. So your server will use this middleware to respond any request that is coming in from client. If the client is sending a request that is not conforming to your API specification, this middleware is going to return back 400 to your client. It's not going to involve server at all. And same thing for the server. If the server returns some response that is not conforming to the Swagger spec, in production we can log some error so we can look at it later, or in development we can just throw a 500 and panic, oh, your server is not conforming to API spec. The other way to use Swagger is to, again, sit down and write your Swagger spec and then generate a test client library. This is something I worked at Apogee when I was working there. So you get the Swagger spec and generate lots and lots of tests for you, because we know when I return this, when I call this endpoint, I'm expecting this shape of JSON. So it tests against those kind of specifications. This is another use case using Swagger as a bridge between RPC to JSON. I'm not going to talk too much about it, but this is good to know that Swagger can be used for leveraging your existing gRPC protobuf-based servers. Here is when it becomes very, very interesting. So now the Swagger is becoming kind of source of truth, because in this case, your server has some Swagger spec in it. The backend guys have written some Swagger. And they have the middleware that is like enforcing the types there. We can also use this API spec to generate a bunch of clients for your API. Because we know how the API looks like, we can generate an API client that is exactly designed for that API. So what I mean by API client is that, like, for that simple API that I just showed you, if I generate the API client in TypeScript and make a new instance of that client, I don't have to know what the path for getting all the foods are. I don't need to know the path name. I just need to know the operation name for the getting all the foods. And that obviously is going to be auto-completed by TypeScript compiler, TypeScript language server. And I also get this nice hint that if I want to get all the foods, I need to pass this parameter. I pass the parameter and get the response back in tightly typed manner. Like the response of this endpoint, which is returning a promise, will be in the shape that JSON schema has described. This is very powerful because now we don't have to guess what the API endpoint returns. The client tells us what the API endpoint returns. It can get even more interesting because the API spec so far, if I go to the previous slides, the API spec is handwritten. Some guy in the backend is writing this API spec. But anything that is handwritten, especially with types, is usually prone to errors. People forget to update them. People don't make the best API descriptions. So what can we do better is to generate this API specification out of the code itself. Because hopefully the code in the backend is well typed, and you can just extract those types from the backend code and generate this nice API documentation that every time you update the backend code, it just automatically generates a new API specification, which generates a new SDK, so everything just works very beautifully. So the way it's going to be done with the type server is you need to have some annotations. You need to have some hints for the API spec generator to tell where this, how this API is looking like. So it's not 100% automatic. You need to do some work. But it is very close to your code, so it is much easier to maintain. I have an example of that. Here is a little bit of code from a framework called Nest.js. If you haven't used it, you should check it out. It's a very, very nice Express-based backend system that is leveraging TypeScript very heavily, and it is pretty modern. I really love it. They also have a Swagger extension that I can just add a bunch of annotation to my API handlers to get descriptions. For instance, here, this function that you see here, this is an API handler for creating a new to-do. I have a bunch of annotations. The first one says, this is a post method. Done. So it's described that this is going to be done by post. So if I make a get call to this endpoint, I'm going to get error message. I'm also describing that this endpoint returning what error codes. It returns 403 if you don't have access, and it returns 201 because that's the proper HTTP code for creating something. And it also describes what the body of this HTTP call that is coming in should be. And that is leveraging the existing types in my type system. And that's very beautiful. So this create cat to do type here is the source of truth for creating the API spec. And the API spec generates this SDK. So you see what happens here. If I change the create cat to do interface, I can get the API client to have this new interface as well. So this stuff are pretty useful. So as you can tell now, in our Lyft infrastructure, we had type servers, type APIs, thanks to the Swagger, and type clients, thanks to TypeScript. But what if these three type systems are not, again, talking to each other? They are not on the same page. This is as bad as not having any types. So we should bring these type systems to the same page. And Swagger and OpenAPI, plus a bunch of other technologies, can help us to get there. So if we need one source of truth, it should be a very good source of truth, and it should be biased. If we go back to the previous slide, the front-end people will be like, we want TypeScript to be source of truth. Back-end persons will be like, I want my MyPy interfaces to be source of truth, and API maintainers are going to be like, we want Swagger to be source of truth. So every team is going to push for their own agenda. So instead of picking any of them, you're going to pick something that works for everyone, and that is protocol buffers. Protocol buffers is a standard for describing messages. It's framework agnostic, language agnostic, and it is well maintained by Google. So this is how a protocol buffer description looks like. As you can see, this is a very easy to get on board syntax. Like for instance, here message person has a bunch of fields, and we know which fields are required, and what the type of those fields are, and all this interesting type information. So if we can use this protocol buffers as a single source of truth for everything, it would be great. So if we take that into account, then this is how the model looks like. We have one protocol buffer definition somewhere checked in, and the server code is using the protocol buffer to annotate the server with Swagger definitions. So it depends on the server language. That's why I don't have an actual code here. But if you have Go, protocol buffers are really well, working very well with Go. With Python as well, we can make it work. And with JavaScript, there is a gRPC node that works very well with protocol buffers. So no matter what the server is, the server doesn't maintain the type information. Type information is within these protocol buffer files. And then the server has a bunch of server annotations to put together these messages interfaces with the Swagger information that, yeah, hey, if I get /foo, I'm going to return this protobufs schema. And if I get /bar, and so on and so forth. So with that server annotations and protocol buffers, we can get a very well-typed TypeScript client that is conforming to these protocol buffers. The good thing about protocol buffer is it can be used for gRPC connections. In fact, it is mostly used for gRPC connections. So for instance, at Lyft, a lot of the servers that we have are talking gRPC to each other, and they do use protocol buffers. So if my backend for the front-end code, this system in the center, is using protocol buffers as well, everything is going to be well typed within this whole infrastructure. And then you get the generated client. So having protocol buffers in the gRPC environment is obviously very, very useful. So if you put all of this together, you know what happens, right? No more bugs. This is for sure what happens. But realistically, there will be bugs, and we will have jobs. But any bugs that is the result of mismatch between how client and server work will be gone. So that's a good thing about this setup, where at least we know that server, client, API, they're all on the same page. It also changes how developer workflow works. Let's say I am a backend person and I hate JavaScript. I don't want to touch that clumsy language. And I make some changes to protobuf, and I make my backend conform to it and push the PR and sit back and take my coffee, and I see, oops, the client build is failing. What happened? Well, the client JavaScript code has not updated according to this new change, and the generated client is not conforming to the actual code that you're using. Like, for instance, that method that client is calling is no longer there, or something like that. So the backend person is going to see the client code fail, and they cannot blame it on us. So good. And then the second part of it is, any change that you want to do, it has to start from the protocol buffer. Protocol buffer has a very, very good system for backward compatibility. It's the designs, I wouldn't go into details, but you don't have to make a new version manually like the way JSON schema works. You can just add new fields and mark fields as deprecated and keep backward compatibility. In fact, like if you use protobuf heavily, a lot of the time that developers spend is on just updating these protobufs. But the good thing about that is, once you update the protobuf, the client in this TypeScript land is changing. The server is now aware of this change. You might get type errors in the server. So it is pretty nice to start from what my objects are going to look like after this change. The thing that a lot of people ask about this is, so the client is a bunch of TypeScript code. And every time I change the protobuf, I need to generate a new client, and that's going to take time. But this is pretty easy to solve. You can just make a watcher that watches that endpoint in your API that generates the Swagger, and just print new API clients in the disk. And the TypeScript compiler is pretty good at picking up changes. And the other note that I want to make is, you probably know that Google or some big organizations, they have one repo for all of their code, which sounds crazy. But it makes sense, because if I had 3 repos, one for protobufs, one for client, one for backend, then I have to make 3 changes across these repos that are in orchestration together to make my change happen. But if I had one repo for everything, I can just make one change list. That's why Google is on monorepo, and every big organizations, they are going to move to monorepo if they want to or not. But in the future, things are going to change a bit. Because all we talked about was how we can transport types over HTTP. But HTTP, if you think about it, the first T is text. But we are using it to transport data. And that is not really ideal. HTTP is not meant for data. Even though I worked on Swagger team, even though I am proposing that we should all use Swagger, but in the new future, you shouldn't use Swagger. You shouldn't use HTTP. You shouldn't use JSON. You should all use protocol buffers and gRPC connections, because they are faster and they're more efficient. They don't have HTTP overhead. They work much better. So this is something that is coming up. Google has this in their proto definitions. There is this google.api.http proto definition, which makes it possible to describe a HTTP endpoint or HTTP API in protocol buffers. So this is very powerful. And it doesn't have to, so you don't have to have server annotations here. You don't have to have server annotations for your API. Everything is described in that protobuf, even the server endpoints, like what operations are allowed. Everything is described there. So this makes it much easier to maintain. So instead of having two places that your API is described, there's just one place, and that is the beautiful protobuf. The other thing that is coming up is gRPC in browsers. We already have gRPC in the server with Node.js and all other languages, but gRPC can also work in the browser. There's a few limitations thanks to how JavaScript works. For instance, in JavaScript, we don't have 64-bit integers, so this statement in the second code block is truthy. Number max value plus number max value plus 2 is equal, which is not good. So protobuf has this type for integers which doesn't fit in JavaScript integers, and this is kind of a blocker. Right now, people are going around it with array buffers. They describe the number in the array buffer and then do crazy math on this array buffer to increment numbers and things like that. But soon enough, we are going to have big numbers in JavaScript. Woohoo! There is a proposal for big int in JavaScript. So you're going to have this new literal syntax. You see this 2n on this corner? That is a number in JavaScript that has flexible width, meaning it can be as big as almost you want. It's not infinite, but it's too big. It's big enough for satisfying almost all use cases. At least it satisfies protobuf int number. And also with gRPC on web and HTTP2 push, we can just connect to a gRPC server from browser and talk to it in binary format. So this is pretty good because you don't have to rely on HTTP and AJAX calls to get your data. Is much faster and more efficient, and more importantly, type safe. That's it, all I had. Thank you for listening, and hopefully soon you guys are going to use Swagger in your APIs.